So here we have another radical equation with a square root. This time I need to move the x over to isolate my square root. So I have 2 minus x equals the square root of 19 minus 2x. Now I am going to square both sides. And if you think about all the times throughout this packet that we have to square a binomial, hopefully it's second nature that you need to write it twice by now. This cancels and we have 19 minus 2x. So distributing over here, I have 4 minus 2x plus x squared, and over here I have 19 minus 2x. So I'm going to bring over the 2x and the 19. I'm also going to combine like terms in the middle. So putting my x squared first, I have x squared minus 2x, and then minus 15 equals 0. Moving over here, we'll factor. That's going to give me x minus 5 and x plus 3 equals 0, giving me answers of 5. And wrote the wrong symbol there, so I'll erase that. And negative 3. So remember, I want to check both of those. I showed a check on page 1, so if you want to go back and do that, basically we're going to plug in the 5 for the x. That ends up not working. When we plug in the negative 3 for the x, and specifically I should have underlined both x's, that makes the equation true. 2 does equal negative 3 plus the square root of 19 minus 2 times negative 3. So my only answer here is negative 3. So remembering these radical equations, and then the square root equation, not the square root equation, sorry, the radical square root equations and the rational equations, the ones with the fractions that we just did as the last question on the last page, are the ones where we really want to check for those extraneous roots or those extra roots that come from changing the type of equation. So our last one on this page is our, super long 3x3 systems, not super hard, but they do take a while and they take a bunch of steps. So let me get this moved down. Now, a couple organizational pieces we learned in class. First off, I want to number my current starter 3 equations. I'm trying to find a triple, an ordered triple, x, y, z here. And my first step, I'm going to look and I'm going to try to find something to eliminate. So looking through the variables, there's nothing that directly cancels right now. I am going to actually choose to eliminate z in this case. Y is not a bad idea either, but I'm going to work from z, okay? So I'm going to start with equations 1 and 2, and I'm going to multiply equation 1 by negative 3, and that's going to make it so that my 2z is going to become a negative 60, and it will cancel out with that 60. So 3x minus 5y plus 2z, we have to multiply both sides by the negative 3. This one equation 2 doesn't need any change because it already has the positive 6z. So we'll distribute down the line, and that's going to give me my new equation 1 is negative 9x plus 15y minus 6z equals positive 15. And this one is 5x plus 1y, I'm just going to write the 1 in there, plus 6z equals 33. So I'm just recopying equation 2. And then we can simply follow the signs and add. So here I have a negative 4x plus 16y. This cancels, and that equals 48. So we also, when we did this the first time, labeled these, that was step A. So for step B is just like step A. I have to make sure I eliminate z again. And I'm going to choose equations 2 and 3. So I'm going to try to create another 2-variable equation. We're going to call this one equation 4. So we're going to create another 2-variable equation that contains x and y. So here, number 1, nope, we said we're going to choose equation 2 and 3. So 2 is already set because it has 6z. We're going to multiply equation 3 by 2 to make the negative 3z a negative 6z. just to show the way we were writing them, we did write the arrows across. I know I didn't do that above, but I'm trying to be conserving of space. Put in that 1y. So that equation 2 stays the same. Equation 3 becomes negative 4x plus 20y minus 6z equals 80. Adding them together, this becomes a 1x, a 21y. This cancels, and we have 113 on this side. So that is, I kind of wish I put it in blue, that's equation 5. So for step C, we're going to take equation 4 and 5, and this is always step C as long as we have eliminated the same variable, which in this case was z in both equation 4 and 5, and we're going to put those together to be a 2-variable system to solve. So I have negative 4x plus 16y equals 48. That's equation 4. That one looks good. I'm going to leave that one as is. Equation 5 has a 1x, so I'm going to multiply it by 4 to create a positive 4x, but I'm not going to write that there, so that it will cancel with the x in equation 4. So we're going to do x plus 21y equals 113. It's going to give me kind of a big number here for the last number, but that's okay. So arrows across, negative 4x plus 16y equals 48, and 4x plus, we got 84y equals 452. So now we're going to cancel, this cancels. 16 plus 84 is 100. 48 plus 452 is nicely 500. So if I solve now, I have y by itself, I get y equals 5. So that's my first of my 3 variables to solve. As long as that went well, the last steps are usually pretty easy. So step D, which I'm going to put up here, is to take that value and plug it into either equation 4 or 5. So I think I like equation 5 better. It's a little easier to work with the 1x. So I have x plus 21 times my new value for y, which is 5, and that is going to equal 113. So I get x plus 105 equals 113, giving me that x, when I subtract the 105, is 8. So my last step, we're going to try to squeeze it in here, is step E. Create some space, we'll see what happens here. So we're going to now plug in our y value and our new x value into one of our 3 original equations. I'm going to choose equation 2. So I have 5, this is equation 2, 5 times 8, which is the x, plus 5, which is the y, plus 6z equals 33. That gives me 45 plus 6z equals 33. I'm going to subtract the 45 and get a negative 12. So z equals negative 2. So my final answers are here, and I can write it as an ordered triple in parentheses, not in squiggle brackets, because it's one answer with 3 separate parts. We get 8, 5, and negative 2.